So, planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new – planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP 18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers model how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all.
Uranus is an enigmatic giant that has puzzled astronomers for centuries. But what sets this gas giant apart from the others is its strange tilt. While most planets spin on an axis that is perpendicular to their orbit, Uranus takes a wild spin in a different direction. But why does it look like this? How did the planet turn out to be lying on its side? And what would we see if we visited the surface of such a planet? Let's find out. Uranus, the seventh planet from the Sun, is a cosmic oddball and source of many jokes. It's one of the gas giants in our solar system, along with Jupiter, Saturn, and Neptune. It's also the third largest planet in our solar system, with a diameter of about 31,000 miles. And one of its many oddities is a weird rotation on its side. Not all planets in our solar system are aligned in a straight line. While most planets in our solar system have an axial tilt of less than 30 degrees, Uranus is tilted at an angle of almost 98 degrees. It's like that one friend who always has to be different, even if it means standing on their head to prove a point. So its north and south poles are facing east and west. It's like the planet got lazy and just rolled over one day, deciding to take a nap. And why is Uranus so tilted, you ask? Scientists once thought this was due to some kind of collision. They thought that something gigantic crashed into Uranus, something like what happened to our Earth. A dwarf planet crashed into it, the Earth tilted slightly, and the Moon was born from the remnants of the collision. But this theory had a problem. In the early universe, there were a bunch of asteroids, dwarf planets, and other large objects. And if this is so, then why is only Uranus tilted? All sorts of guys have crashed into other planets too, but they don't have such features. But recently, scientists have published a new study, and now scientists think that the culprit might be a long-lost moon that wandered away. Back in the days of the early solar system, the giant planets partied much closer together and way closer to the sun. But, as we all know, parties can get out of hand. Something caused Uranus and Neptune to migrate the farthest, like they were trying to get away from the sun's strict supervision. Each giant planet had a collection of moons, but they were constantly getting shuffled around during all this migration madness. Some planets lost moons, while others gained new ones. Uranus could have been born with a massive moon, or quickly captured one, and if that moon was big enough, it could have started playing games with Uranus's spin. This moon pulled on Uranus with its gravity, making the wobbling even worse. As time went on, it made Uranus tilt more and more. Eventually, it crashed into the planet, locking it into its current tilt. While the theory is pretty sound, based on computer models, we'll have to wait until at least 2030. That's when China plans to launch the Tianwen-4 spacecraft to take a closer look at Uranus and study it more. Who knows what other crazy space secrets we'll uncover next? Until then, we can all have a good laugh about the lazy, rebel planet that just can't seem to stand up straight. Such a funny and unique feature makes you wonder, what exactly would we see if we were standing on this planet? How would its strange tilt affect the view from its surface? Let's see, if you were standing on the surface of Uranus, although it doesn't really have a surface, it's more like a gas atmosphere, you'd enjoy a cool view. You'd see the sun rise in the east, just like on Earth, but then it would keep going around the sky in a tilted path, like a lazy spiral. About the sunset though, I hope you have some patience, because it would take 42 years for the sun to complete one full circle around Uranus's sky. That's a really long time to wait before finally going to bed. But speaking of the sky, it would be a beautiful sight to behold. Uranus is known for its stunning, unique blue-green color. It's caused by the methane gas in its atmosphere. Methane absorbs red light, giving Uranus its cold hue. You'd also see some amazing clouds and storms swirling around the planet. But if you're looking for constellations, you're out of luck. The extreme tilt of Uranus means that its poles face towards the sun, so the stars would be all over the place in the sky. The constellations that are familiar to us would be unrecognizable from Uranus. Also, as the planet rotates, the position of the stars would change very often. For you sailors out there, good luck in navigation. But you could see its beautiful moons. Uranus has 27 known moons, with the largest being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. These moons are thought to have formed from the same material that formed Uranus, and yes, the tilt affects them too. They orbit around the planet perpendicular to the planet's motion around the sun. And they aren't the only ones. Did you know that Uranus also has rings? Yeah, not only Saturn is so special. The rings are made up of ice particles, some as small as grains of sand, and others as large as several feet across. They're thin, narrow, and dark compared to Saturn, for example. They're actually so black that they almost don't reflect the light. That's why it's so difficult to see them from Earth. But if you were near the surface of Uranus, you might be able to see them in the sky. The only question is, would you even be able to focus on all these views? Because Uranus is extremely cold, and that will probably be the only thing you'd think about. We're talking about temperatures that can drop down to negative 350 degrees Fahrenheit. Brr, better pack some warm clothes for this trip. This is because it's so far from the sun, and its atmosphere is composed mainly of hydrogen and helium. And not only is Uranus the coldest planet in our solar system, but the winters there are long. Due to the extreme tilt, it has seasons that last for over 20 years. It's like the planet is stuck in a perpetual state of winter, which is both cool, pun intended, and kind of sad at the same time. And if that's not cold enough, Uranus is also known for its strong winds. In fact, they can blow up to 360 miles per hour. So you might want to hold on tight to something, or wear a windproof suit to avoid being blown away like a leaf. And finally, Uranus's magnetic field is also tilted at an angle of 59 degrees from the planet's axis of rotation. This creates some interesting effects. The most obvious one is beautiful auroras, which are similar to the northern and southern lights on Earth. On Uranus, however, the auroras are located near the planet's equator rather than at the poles. Isn't that cool? The result is a dazzling light show that would make even the most jaded space traveler stop and stare in wonder. But even though it sounds pretty awesome, it makes it more difficult for spacecraft to navigate around Uranus. The magnetic field creates a lopsided gravitational pull that can affect the trajectory of spacecraft. This makes exploring Uranus a bit more challenging, but maybe it will change in the future. All in all, standing on Uranus would be a chilly, wobbly, and breathtaking experience, and definitely not your average stroll in the park. Next time you look up at the night sky, think of this beautiful icy planet, and remember that even in the vast expanse of space, there is always something new and exciting to discover.
As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So hold on tight, the future of exoplanet discoveries is looking brighter than ever. Number 1. New type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line, where surface temperatures are freezing. But they later migrated closer in, to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2. Jupiter-sized world. Imagine a planet so massive and mysterious, it's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just. We've named it the TOI 2180b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees Fahrenheit. For comparison, the temperature on Jupiter and Saturn is around minus 280 degrees. It's like a bridge between the giant exoplanets we've found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we get some answers soon. Number 3. The Hulk planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1922 degrees. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog! Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These gas giant planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1 million years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called superjupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown into the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron. And yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery, and a puzzle we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6. The Football Planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet, and it's unlike anything we've ever seen before. Meet WASP-103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter. It's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7. A zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. A team of researchers analyzed 47 potential habitable exoplanets named Kepler 69c, Kepler 1229b, and Kepler 395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8. A planet with silicate clouds. Introducing VHS 1259b, not a home video recording system, but a strange and exotic world shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter, but it's not quite a star. It's something in between, a cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet, and it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets. But this is just the beginning, as scientists and researchers continue to explore the vast expanse of space. We can only imagine what other wonders await us. So, let's keep looking. Who knows what secrets the stars hold for us next?
Wow, the James Webb Telescope has been fully deployed! If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant. And elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets, and the first galaxies in the universe, and stars and planets forming inside nebulae. And you can bet that there'll be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view. And the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires 2 other cutting-edge technologies, the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sun shield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sun shield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a 3rd temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute zero. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.
Now, you've seen those breathtaking images from NASA. Stars born in clouds of gas, tangled galaxies, colors that look fantastic and vivid. And then someone suddenly says that this isn't real, that NASA edits all these pictures. Well, guess what? They're right! NASA does edit their photos, every single one. The catch is that it's not to deceive us, but rather to reveal what we could never see on our own. You see, color is a weird thing. It's just waves of light and energy flying through space. When these waves hit some object, a banana, a chair, or even a dust particle, the objects absorb some of the waves, eating a part of the spectrum. But some of it bounces back into our eyes. That bounced light is what we perceive as the object's color. There's an entire spectrum of these waves, from short ones to long ones. As they get longer, they move to the red spectrum and turn into infrared, microwaves, and radio waves. As they get shorter, they move closer to blue and violet, turning into ultraviolet, X-rays, and gamma rays. Now, right in the middle of that spectrum is a tiny band we call visible light, which is the only part our eyes can see. That's the rainbow we all know and love, and it's an exceedingly small part. So, you might say we barely see the world at all. When light bounces off something and gets into our eyes, our color-detecting cells, called cones, send them to our brain. So, when we say, banana is yellow, it means banana ate red, green, and blue waves and reflected yellow waves into our eyes. So the question is space actually that pretty and colorful, or is it all fake? Well, yes and no. Stars emit light, and it travels through space like an unstoppable train. It's flying there, chilling, until it hits something – dust particles, a planet, spaceship, or an astronaut. Every time light hits something, some of it gets absorbed, some of it reflects and continues to travel. So we get less and less light every time it hits something. And when you enter a nebula, which is basically tons of dust particles around a gas cloud, light quickly starts to scatter and disappear. Nebulae, which is the plural of nebula, also grow naturally from ionized gases like hydrogen, oxygen, sulfur, radiating light in specific spectral lines. But it's super faint as well. Remember, our eyes see things only when light bounces off those things in our eyes. On top of that, the color-detecting cones in our eyes aren't so great, in that they need lots of light to activate. We can't see faint stuff. Unless there's something emitting light right there nearby, we wouldn't see anything. In other words, for us, the entire space would be like a room with lights turned off. The potentially beautiful nebulas and planets are there, but if you don't have a lamp nearby, you can't see them in all their glory. When there's lots of light around, rods take over, another type of cell that's great for motion and dark vision, but terrible for color. So in deep space, all we'd see are dim whites and grays. Now, if you were flying around on a spaceship, the stars would look sharp, white, and non-twinkling. You'd be able to see some reddish or bluish tints to the brighter ones, like Betelgeuse or Rigel. But a lot of things would be dim gray smudges at best. The Milky Way might appear as a cloudy band, not rainbowy like in astrophotography. Nebulae would look like faint fuzzy clouds with no color, unless it's something that glows very brightly, like the Orion Nebula. In our solar system, astronauts can see stuff thanks to the sun or when they're near illuminated planets or spacecraft. Planets like Jupiter and Mars retain some color for our eyes. Meanwhile, on Earth, the sky would look black during the day if we had no atmosphere. The sun would be a bright disk in a void as seen from the moon. If only we had super-sensitive cone cells that could detect light better than we do and see even faint things. Oh wait, we actually do have technology for that. Long-exposure cameras and telescopes. Now, telescopes are great for that. They often use long exposures to gather light over minutes or entire hours. That lets them capture photons we'd never collect with our eyes. When telescopes like Hubble or the James Webb take photos, they're not snapping pretty pics like those on Instagram. They're collecting all this raw, invisible data, numbers and faint light that's both within and beyond human vision. The James Webb Space Telescope doesn't even see visible light. It's built to detect infrared or heat. Telescopes like that work like time machines. They show not only distant galaxies, but also what those galaxies looked like billions of years ago. We see stars that have long since gone out, and galaxies that may have already disappeared. All because the James Webb can pierce through gas and dust and see galaxies so old that their light has been stretched into infrared wavelengths as the universe expands. In other words, this telescope isn't made to let us take aesthetic photos. Its main goal is to study the history of the universe. Now, at first, this stuff looks like grayscale or even black images. When the James Webb sends data back, it looks empty. But during post-processing, astronomers map wavelengths they received to visible colors. Every color in those pictures is chosen for a reason. It highlights specific wavelengths, gases, or temperatures. In any case, it shows what would otherwise be completely hidden from our eyes. Sometimes they show only stuff a human eye can see. Sometimes they shift colors or add something to show elements or intensities. For example, let's say you're studying a supernova, a star blowing itself to pieces. You need to see its debris clearly to understand what's going on. That means you'd play with the contrast or adjust color balance to reveal specific gases and find pale objects near bright ones. Want to check out a weird rock on Mars? You zoom in, adjust the lighting, boost the shadows. Photographers do this every day. So scientists do it too, because clarity means understanding. Even old photos from the Apollo missions have been touched up in modern times. It's like restoring an old film so it looks crystal clear instead of foggy. Without this editing, the most incredible discoveries of the past 2 years, those first galaxies, those newborn stars inside cosmic clouds, would just look static. Is it possible to accidentally misinterpret the color? Of course! For example, images we get of Mars are mostly red, but when we land on a planet, it's more colorful. Most of it is gold, yellowish, tan, or brown. The reason Mars looks reddish is due to rusting iron in the rocks, Martian soil, and dust. It all depends on the lighting, atmospheric dust, and image processing methods. But the fantastic colors themselves are not made up. Galaxies contain billions of stars, gas, and dust, giving off incredibly rich color ranges. NASA's photos are basically translations. Now here's an interesting take.
Could we use goggles with night vision or some technology that makes our eyes notice light better, like working with Hubble or the James Webb? Man, the sky would be insane. You'd never be able to sleep again. These magical astronomy glasses should greatly amplify faint light, enhancing and translating colors. Unfortunately, today's night vision tech won't cut it. Night vision goggles work by amplifying visible and near-infrared light, but they display everything in green monochrome, not true color. Meanwhile, infrared goggles detect heat, not color. We need some goggles that raise photon sensitivities by 10,000 or so. If only we were lucky enough, like some animals. For example, snakes can see infrared, bees see ultraviolet light, and birds see more colors than we do. And we can't even imagine how they perceive the world. So yeah, NASA edits their photos, because raw space isn't built for our eyes. It's dark, cold, distant, and silent. But with a little translation, some math, some color grading, some visual storytelling, we can see the invisible. We can study the past and inspire more people to study space in the future.
It was the year 2017 when astronomers spotted a bright star hurtling out of the Milky Way. It was moving incredibly fast at a speed of 2 million miles per hour. That's almost 4 times as fast as the Sun orbits around the center of our home Milky Way galaxy. It takes our star more than 225 million years to complete one journey. Anyway, back to our star, the Wanderer. The main issue with it was that it was moving against the direction in which most stars travel around the center of our galaxy. Even more bizarre, it consisted of totally different star stuff. Astronomers managed to identify its composition. The star was made up of heavy metallic atoms. At the same time, most of the other stars consist of way lighter elements. The wandering star got the name LP-40-365. It was moving so fast that it literally dashed out of our galaxy. This made scientists believe that the space traveler was pushed out of its place by some kind of cosmic disaster, like a supernova. A supernova is the largest explosion that can take place in space, an explosion of a star. It happens after irreversible changes start in the core of a star. Supernovas can occur in 2 ways: in binary star systems and when there's a single star. Binary stars are 2 stars orbiting around the same center. At some moment, one of the stars, a very dense white dwarf, starts stealing matter from its companion. After some time, this thief accumulates too much matter, which causes it to explode into a supernova. Or it can be a single star nearing the end of its life. It's running out of its fuel. More and more mass is flowing into the core of the star. In the end, the core becomes so heavy that it fails to withstand its own gravity. After the core collapses, a tremendous amount of energy is released in a supernova. But astronomers still can't figure out how a supernova could send LP-40-365 flying. There are more questions than answers. Was it a companion star that got flung out by a shockwave created by a supernova? Or was it a piece of the exploded star? A new study based on the collected data has shown that the star, which is a white dwarf, keeps slowly rotating around its axis. Astronomers are almost sure it means LP-40-365 is indeed just a chunk of space debris, and not a full-fledged star. This wandering piece somehow managed to survive one of the fiercest space events. But after making such a conclusion, scientists realize something amazing. LP-40-365's unusual features could appear after the star witnessed a supernova. Even though this event happened lightning fast, the entire makeup of the star got changed. Most stars consist mainly of helium and hydrogen, but LP-40-365 is different. It contains such heavy elements as magnesium, oxygen, and neon. It must have been the supernova that added these atoms to the star's composition. By the way, astronomers consider all elements that are heavier than helium to be metals. This means that after witnessing the supernova, LP-40-365 became metallic. Right now, the star doesn't have its own planets, but NASA's Transiting Exoplanet Survey satellite, which is on the lookout for distant planets passing in front of their host stars and dimming them, has noticed a curious thing. LP40-365 brightens and then dims again every 8.9 hours. It might mean that the star pulsates, but usually stellar pulsations are much less regular. A more plausible explanation is that the star's surface is uneven, and as it spins, sunspots are brought into and out of view. And it's great news, because after astronomers figure out how fast the star rotates, they can understand what happened to it around 5 million years ago during the supernova. Bright blue exoplanet HD 189733b looks peaceful and eerily familiar. Doesn't it resemble Earth? But this appearance conceals the planet's terrifying nature. There, the winds blow at 5,400 miles per hour. It's 7 times the speed of sound. But that's not the worst. It rains glass, sideways, in this scorching hot world. Neutron stars are ultra-dense collapsed cores of giant stars. They emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. The most plausible theory is that this signal was probably produced by a disk of dust surrounding the star. But there isn't enough evidence to confirm this idea. Mercury is the fastest planet in the solar system. It zips around the sun at a breakneck speed of more than 100,000 miles per hour. That's around 40,000 miles per hour faster than our home planet. It's one of the reasons why a year on Mercury equals 88 days on Earth. Mercury is the planet that orbits the closest to the sun. That's why if you were standing on its surface at its closest approach to our star, the sun would look more than 3 times as large as it does on Earth. The Black Widow pulsar is a rotating neutron star that is munching on its partner, which is a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. There's a stellar nursery in the constellation Centaurus, and even though this place is called a nursery, it's anything but peaceful or safe. It's made up of hydrogen and newborn stars and is located in a nebula around 6,500 light-years away from Earth. A nebula is a giant cloud of gas and dust floating in space. The intense energy baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful, it's eating away dark clouds of dust. Astronomers can see them disappear like lumps of butter on a hot frying pan. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice, and this ice is burning. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means the exoplanet travels very close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X. And this ice remains solid despite such incredibly high temperatures. Jupiter is the largest planet in the solar system. It's 318 times as massive as Earth. It's also 2.5 times as massive as all other planets of the solar system combined. But here's a paradox. If this gas giant got even more massive, it actually becomes smaller. The added mass would make the planet denser, and this would cause it to start pulling in on itself. Astronomers claim that Jupiter can eventually end up being 4 times as massive as it is now. But at the same time, its size won't change. DGSAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thin. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DGSAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Saturn's moon, Hyperion, is one of the most bizarre-looking moons in the solar system. But the appearance isn't the strangest thing about this space body. The pumice stone-like rock is pockmarked with countless craters, and it's also charged with static electricity, which is flowing out into space. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Ceres is the most massive space body in the asteroid belt between Jupiter and Mars. It totals almost a third of the entire mass of the whole belt. But at the same time, Ceres is the tiniest of the dwarf planets out there. It's also the only dwarf planet that dwells in the asteroid belt, and also the only one that is located in the inner solar system. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen. But its mass isn't enough to start a fusion reaction in its core. And that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 70 times its current mass. Space is completely, eerily silent. That's because in the vacuum of space, there's no atmosphere, and the sound waves need some medium to travel through. That's why worlds with atmospheres like Earth are full of noise. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have enough mass of 1,000 sedans. One theory claims that tons of micro black holes could be created right after the Big Bang. Some scientists even go so far as to say that a couple of mini black holes pass through our planet every day. Every hour, the sun sends more energy to Earth than our planet uses in a year. Even though people are now using much more solar energy than a decade ago, it's still a mere 0.7% of the world's annual electricity usage. There might be moons orbiting other moons, but astronomers haven't agreed on this theory yet. Planets orbit stars, moons orbit planets. But why can't there be moons, also known as submoons, moonettes, and moons? Researchers claim that moons could exist, but the host moon has to be massive enough and the moon small enough. There must also be a large distance between these moons and the host planet. Jupiter is the most massive planet in the solar system. This means its gravity is also the most intense. It's 2.5 times as great as what we have on our home planet. Once, the gas giant's gravity even tore apart a large comet called Comet Shoemaker-Levy 9. Then the planet eagerly swallowed the chunks of the former comet. If you were standing at the equator on Mars, the temperature at your feet would feel like that of a warm spring day, but your head would be literally freezing. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars, but one of them, floating 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates never-ending flashing auroras in the planet's atmosphere. Europa is one of Jupiter's largest moons, even though it's smaller than Earth's moon. But the cool thing about this satellite of the gas giant is that it's covered with ice. And some of this ice is smooth, which means you could skate there. And a 3-foot axle jump you can perform on our planet would take you 22 feet into the air. At the same time, the landing speed on Europa would be the same as it is on Earth. Haumea, a dwarf planet orbiting the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Astronomers haven't managed to figure out how or why it appeared around the dwarf planet. 11 Earths could fit across the equator of Jupiter, and if our planet was the size of a grape, the gas giant would be as large as a basketball. 9 spacecraft have already visited Jupiter. 7 of them just flew by, and 2 orbited the huge planet. The most recent of them, Juno, arrived at Jupiter in 2016. The craters of the moon's south pole are likely to be the frostiest place in the whole solar system. The crater's floors are always in the shadow. That's why the temperature never rises above 397 degrees Fahrenheit, even during the day. If you decided to fly a plane to Pluto, your journey would take around 800 years. You'll find the highest mountain in the solar system on an asteroid called Vesta. Its peak rises 14 miles above the base of the mountain. This makes Rye Sylvia, that's what the mountain is called, almost 3 times taller than Everest. Saturn's rings weren't discovered all at once. It happened gradually. That's why they were named alphabetically in the order scientists found them. Now they go like this: D, C, B, A, F, G, and E. A day on Venus is around 243 Earth days long. But the bad news is that you'd have to wait for a weekend for 3 years. All because a day on Venus is longer than its year. A solar phenomenon called terminator events is taking place at the Sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen almost every decade. The winds on Neptune are the fastest in our solar system. Most of them can reach the speed of 1,600 miles per hour. Almost any of these enormous storms could easily swallow our entire planet. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because a ring of dust and debris circling it makes it look like a giant eye staring into your soul. The intimidating star is more than twice the mass of our Sun and is 25 light-years away from Earth, which isn't that far away considering distances in space. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, the planet's gravitational forces will tear Phobos apart. It'll probably result in the formation of a ring around Mars. An asteroid the size of a car enters the atmosphere of our planet every year. Such an intruder could wipe out a small town off the face of the Earth. Dust and smoke would rise into the atmosphere, preventing sunlight from reaching the surface of the planet. It would cause the temperatures all over the world to drop and the climate would change. Luckily, such asteroids burn in the atmosphere before they even come close to the surface. The radio signal produced by a spacecraft when it contacts Earth is less powerful than a light bulb in your fridge. By the time this signal reaches our planet, its power is only 1/1000th of a watt. No wonder that antennas gathering these super weak signals are huge. The Deep Space Network that detects signals from spacecraft has dish antennas that measure up to 230 feet across. That's more than the width of a soccer field. In 1999, NASA lost a Mars orbiter because one engineering team was using the metric system, and another was doing calculations with the help of the imperial system. Nebulas are giant clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger. And their gravity gets more powerful. One day, a nebula's mass becomes so great that it collapses under its own gravity and forms a new star. Around 4,000 light-years away, in the constellation of Scorpion, there is the Butterfly Nebula. Its wingspan is greater than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an insane 450,000 degrees Fahrenheit. This means it was formed from another huge star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. If you decided to lump together all the known asteroids in the solar system, their total mass wouldn't exceed even 10% of the mass of our moon. A cloud of water vapor is floating in space. It surrounds a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers think this water cloud appeared just 1.6 billion years later than the universe itself. The densest objects in space are neutron stars. They're the size of a small city, yet their mass is about 1.4 times the mass of our Sun. A single teaspoon of neutron star material would weigh 1 billion tons. And a neutron star's gravity is 2 billion times stronger than the gravity of our planet. In 1993, the Galileo probe was traveling past a miniature asteroid. It was no more than 20 miles across, and still, the tiny thing had a 1-mile-wide moon. Astronomers have discovered tons of moons orbiting minor planets in the solar system since then. We live inside the Sun. The star's atmosphere stretches way beyond its visible surface, and our planet is well within its reach. That's how the gust of the solar wind creates such a breathtaking phenomenon as the northern and southern lights.
Attention! Attention! Emergency alert! This is not a drill. The Milky Way is on fire! I repeat, the Milky Way is on fire! Evacuation protocols activated. All terrestrial life forms are to be moved to the Andromeda Galaxy immediately. I repeat! Wait, a fire in our home galaxy? It all comes down to the incredibly hot gas surrounding the Milky Way. This isn't just intensely hot, it's also existed for billions of years. But what's heating this gas and keeping it that way? The Milky Way holds far more gas than stars, and this gas is crucial for forming new stars. Over billions of years, this massive reservoir has allowed the galaxy to keep producing stars. But this gas is incredibly thin and spread out, which makes it next to impossible to observe it directly. For a long time, this made it difficult to figure out how much gas the Milky Way really contains. But in recent decades, researchers finally confirmed that the galaxy is indeed surrounded by an enormous sphere of hot gas. This gas cloud extends as far as 700,000 light-years from the galaxy's center and reaches temperatures of several million degrees. At first, scientists thought the gas's insane temperature was due to the Milky Way's gravity. They believed that gravity caused the gas to swirl around, keeping it from falling inward and heating it up in the process. But then, recently, scientists have discovered something even more surprising: a second layer of gas. And it's even hotter. How did we discover this gas with a temperature of around 18 million degrees Fahrenheit? Faint X-rays coming from all directions in the sky revealed the presence of this gas. The gas also showed up as it absorbed light from distant quasars, bright objects far outside of our galaxy. No wonder scientists began looking for the sources of heat that could explain this bizarre phenomenon. They soon found that the two types of gas, the X-ray emitting gas and the absorbing gas, came from different regions in the galaxy. The X-ray emitting gas is apparently produced by a puffed-up region around the Milky Way's stellar disk. This region is a direct result of the galaxy's star formation, which is still going on. Massive stars in these regions eventually explode as supernovae, releasing huge amounts of energy. This energy heats the surrounding gas to extreme temperatures. The gas heated by supernovae becomes turbulent, moving around chaotically. Some of it escapes into the space around the galaxy, while some of it cools down and falls back toward the disk. This continuous cycle of heating, cooling, and movement keeps the hot gas layer visible in X-rays. The absorbing gas is enriched with elements like sulfur, magnesium, and neon. These elements are created inside massive stars through nuclear reactions and escape into space during supernovae explosions. Runaway stars that are flung out of the Milky Way's disk also contribute to this process. When they explode as supernovae, they create pockets of enriched gas above the galaxy's disk. The X-ray emitting gas forms a glowing layer around the Milky Way's disk. This layer never disappears due to the star formation and supernova activity happening in the galaxy. Together, these processes explain both the absorbing and emitting signals observed by astronomers. Star formation, supernova explosions, and gas movement all work together to shape the Milky Way. The hot gas not only helps regulate star formation, but also redistributes materials created inside stars. And elements produced in stellar cores are spread throughout the galaxy by supernovae. becoming the building blocks for future generations of stars. The research team plans to keep observing the gas at other wavelengths of light. This might give us even more information about how the gas behaves and what it's made of. And once we understand the dynamics of this gas, we're likely to learn more about how galaxies like the Milky Way evolve over time. We need all the data we can collect after all. We don't even know the true shape of our galaxy yet. Recent discoveries have revealed that the Milky Way is not a flat disk as previously thought. No, it has a warped structure. And the craziest thing? Dark matter might be the cause of this deformation. The first confirmation that the Milky Way isn't a perfectly flat disk came from observations by the Gaia spacecraft. Gaia mapped the positions and movements of over 1 billion stars, and its observations showed that the Milky Way extends farther outward than initially believed. At its edges, the galactic disk was a wavy, warped structure with serious deformations along the outer edge. But what causes the warp? These deformations may result from ancient galactic collisions, like the Milky Way's collision with the Sagittarius dwarf galaxy around 6 billion years ago. However, a new study suggests another possibility. The warp might be caused by a tilted dark matter halo surrounding our galaxy. Dark matter halos are invisible, yet massive structures surrounding most galaxies, including the Milky Way. These halos contain most of a galaxy's mass and have a strong gravitational influence on the galaxy's structure. If a dark matter halo is tilted relative to a galaxy's plane, its gravitational effects could distort the galaxy over time. To figure out whether this theory is true, researchers used data from highly detailed computer simulations that modeled galactic evolution, seasoning the process with dark matter and interactions between matter and magnetic fields. The analysis revealed that the inner region of a dark matter halo can indeed tilt significantly with respect to a galaxy's plane. This tilt could result from galactic collisions or close encounters with other galaxies. Such crooked halos can stay this way for billions of years, which is long enough to warp the galactic disk. At the same time, this phenomenon isn't something unique. Astronomers have observed warped planes in other galaxies as well. In fact, nearly half of all spiral galaxies in the universe have warped disks. So, tilted dark matter halos and their gravitational effects might play a widespread role in shaping galaxies over time. While we're looking for answers, the Milky Way continues to shine brightly. But what kind of space electricity keeps its lights on? What fuels the process of star formation? After all, roughly one sun-sized star is born each year in the galaxy, and it needs a lot of fuel. Star formation requires hydrogen, the most abundant element in the universe. But it would still have been depleted long ago, unless there were a replenishing source. The source might be fast-moving hydrogen clouds raining down into the galaxy's disk. The hydrogen fueling the Milky Way is ionized, making it challenging to detect. Unlike atomic hydrogen, which emits light, ionized hydrogen does not. Instead, it absorbs light, which means it can only be observed when it passes in front of a bright background source. Before, astronomers used quasars, extremely bright distant space objects, as backlighting to detect these gas clouds. Unfortunately, in this case, it was impossible to determine how far away the clouds were. They could have been located anywhere between the Milky Way and the quasars billions of light years away. To pinpoint the location of the gas clouds, astronomers turned to the cosmic origin spectrograph aboard the Hubble Space Telescope. They observed 27 stars located within 10,000 light-years of the Milky Way's disk. They analyzed the stars' light and found that about half of the stars were obscured by gas clouds. It means they were close enough to directly feed the Milky Way's disk. The researchers calculated that the gas clouds contained a total mass equivalent to a whopping 110 million suns. This vast reservoir of hydrogen offers more than enough fuel to sustain the Milky Way's star formation. But where did those clouds come from? So far, it still remains a mystery. There are two main possibilities. The cloud might consist of hydrogen formed shortly after the Big Bang, primordial gas. These structures could have remained outside any galaxy for billions of years, only recently falling into the Milky Way's gravitational pull. Or the clouds might be made of material ejected from the Milky Way itself. When stars explode as supernovae, they can blow gas outward. Over time, this material could cool and fall back toward the disk, forming the clouds. We'll be able to figure out the origin of the clouds only after studying their chemical makeup. Gas from exploding stars contain heavier elements, while primordial gas created after the Big Bang is composed almost entirely of hydrogen and helium. Future ultraviolet telescopes could provide the detailed measurements needed to settle the question.
Dozens of spacecraft and hundreds of probes take off from Earth and head for our planet's twin sister, Venus. It's about the same size as the Earth and has around 80% of our planet's mass. The temperatures here are too high for humans, and it doesn't have the air we're used to breathing. But we went there because scientists recently found traces of phosphine gas, which suggests that life might be there. Phosphine comes from various microbes and bacteria, so humanity goes on this journey to discover this life. With our technology, a flight to Venus would take 3.5 to 6.5 months, but we finally made it. Spaceships are landing on the planet, and when the first humans come to the surface, they see heat-scorched deserts, lava lakes, and geysers of poisonous acid. And that's it. Scientists miscalculated the radio telescope data. Phosphine never existed on Venus. So we're going back to the rockets, and we're getting ready for a longer trip across our galaxy. The scientists believe that there's at least 36 civilizations in the Milky Way that are similar to ours. They could be living organisms completely different from us. They may have different bodies, different eyes. They may walk and talk in a very different way than we do. But an advanced civilization has several criteria: technological progress and the use of developed communication between individuals. So, these civilizations must explore space, build cities, and be able to communicate with each other as independent species. Let's look at our galaxy and find these civilized worlds. So, the Milky Way is a spiral of 100,000 light years from side to side. If a star is born at one end of it in a super powerful blast, the light from that event won't even reach the other end until 100,000 years later. There's about 100 billion stars, and near each of them, there may be worlds similar to our solar system. Let's try to find these habitable worlds using giant sieves. First, we look for stars that have a lot of iron. Such stars burn at the perfect temperature for the development of life. And the iron in the star system will help form the cores of planets that will be home to another civilization. We sift the Milky Way through our sieve. We see that there are too many stars that fit the description, so we need another filter. Now let's find stars that look like the Sun in this pile. The star must be about 100 times larger than the Earth and 333,000 times heavier. An important criterion is the age of the star. When a star gets old, it begins to expand and turns into a red giant. At this time, it can absorb the planets around it. The life of such a star can end with a huge blast that destroys everything around it. So the star we're looking for must be relatively young. Let's use our sieve again. There's fewer stars, but still that's a lot. Now let's focus on the planets. They should be in the habitable zone of the star. Not too close to a star because then the temperature would be too high for life to be born. And not too far away. Then the planet would just be an ice block with nothing living on it. The temperature of the planet must allow the water to remain liquid. Another filter is the age of the candidate planet. It takes time for an advanced civilization to develop. Based on the experience of Earth, scientists believe that it takes at least 4.5 billion years for any life form to evolve to the human level. So we're looking for planets similar to Earth or older. We use our sieve one last time, and voila! We have 36 worlds where an advanced civilization is possible. Scientists conducted this study and published it in April 2020, based on these very criteria. All that's left is to discover these civilizations and make the first contact. We can detect such a civilization by using radio waves that come from it. Suppose there's a planet A with primitive living organisms on it. Millions of years of evolution, and they'll become a civilization with advanced technology. Radio waves will be the way they communicate. Then the whole planet will emit radio waves like a star emits light. And here on Earth, we'll be able to pick up this signal with antennas pointed into space. But there's a problem with the distance between the planets. For example, Planet A is 1,000 light-years away from the Earth. When Planet A starts emitting radio waves, these signals won't reach us until 10 centuries later. We learned to emit and receive radio waves in 1895. And if the civilization on Planet A emitted a radio signal at the same time, we won't be able to pick up that signal until 2895. It'll be the same on Planet A. We sent a message in the form of a radio signal into space in 1974. In this signal, we encoded our number system, human DNA, and information about our solar system. If there's an advanced civilization on Planet A, they'll be able to receive this signal only in 2974, and we'd have to wait another millennium to get a response from them. Another problem with radio waves is that they don't look like a constant glow on the planet, but like a flare. Radio waves are only used at a certain stage of civilization. At first, it's the primary method of communication, but then we begin to use cell phones, cable TV, and fiber optics. And as technology advances further, our radio wave light begins to fade out. So we only have about 100 years of active radio use by civilization to find it. One day we caught a strange radio signal of an unknown origin. Its characteristics suggested that the signal was created artificially, perhaps by an outer space civilization or a passing starship. Further searches for this signal given no results, and this gave rise to many theories and arguments as to what it really was. It could have been a signal from Earth that reflected off a satellite flying through the sky, or it could have been the traces of a comet a few light years away. But let's assume it was a civilization from outer space, one of those 36 that probably exist. Now we need to make contact with them. So we throw our luggage into a rocket and head out in the direction of our suspected planet. Our rockets can fly at 17,600 miles per hour. That means a rocket could cross the entire United States in just 8 minutes. But even if an advanced civilization lived near our closest star, Proxima Centauri, it would take us about 73,000 years to get there. Even at the speed of light, it would take 4.2 years. So we need to solve the problem of space travel. Our scientists plan to reach about a quarter of the speed of light with a laser. A powerful laser beam from Earth will push a microscopic probe in the right direction. This probe could reach our destination in about 17 years. And in another 4 years, when the signal from it reaches Earth, we'll know if there's an advanced civilization. Another possibility for faster-than-light travel is the warp bubble spacecraft. The spacecraft would have to compress space in front of it and stretch it behind its tail. Then we'll be able to reach any point in the universe in literally a few seconds. But such travel remains a fantasy for us. Perhaps we can get to different corners of the universe through wormholes. They're shortcuts similar to tunnels, but there's one problem. These wormholes might be inside black holes. They're the most mysterious objects in the universe. They're so heavy that even light can't escape their trap. Our spaceships wouldn't stand the tension either. There's also a theory that Earth is unique because it was born under completely accidental circumstances. 4.5 billion years ago, our planet was a block of lava that began to cool and solidify. But its tranquility was broken by an asteroid the size of an entire planet flying by. The collision occurred at such an angle that the Earth was not completely destroyed, but part of the asteroid remained in our orbit. A heavy rock near our planet stabilized Earth's rotation, and the gravitational interaction with the giant debris caused our core to heat up. In addition, the asteroid brought a lot of water to Earth. Such a collision is extremely unlikely. It's like winning the lottery, many times in a row. But so far, we have no reason to believe life in outer space exists. Just as we have no reason to believe that there's no advanced civilizations in the universe, except for ours.